Today's question is: what are subatomic particles? Everything around us, air, water, plants, even your own body, is made of tiny building blocks called atoms. For a long time, scientists believed that atoms were the smallest units of matter. But later, they discovered that atoms are not solid or indivisible. In fact, atoms are made up of even smaller pieces called subatomic particles. These are the tiny parts inside an atom that give it structure, mass, and behavior. In simple terms, subatomic particles are smaller than atoms, and they are the true foundation of all matter in the universe. Here are the three main subatomic particles. The first one is protons. Protons are tiny particles found in the nucleus, the center of the atom. Each proton carries a positive electrical charge. This charge is important because it helps define what element an atom is. The number of protons in an atom is called the atomic number. It's what makes one element different from another. For example, hydrogen has 1 proton, while carbon has 6 protons. Knowing the atomic number helps scientists identify the type of atom they're working with. Number 2, neutrons. Neutrons are also located in the nucleus right next to the protons. Unlike protons, neutrons have no electric charge. They are neutral. An easy way to remember this is that neutron sounds like neutral. Even though they don't carry a charge, neutrons play a crucial role. They help stabilize the nucleus. If there were only positively charged protons inside, they would repel each other. Neutrons reduce this repulsion and keep the nucleus together. And number 3, electrons. Electrons are the smallest of the three main subatomic particles. They have a negative electrical charge and move rapidly around the nucleus in regions called orbitals or energy levels. You might imagine them like tiny planets orbiting the sun, but in reality, they exist in fuzzy clouds rather than fixed paths. Electrons play a big role in chemical reactions. When atoms share, gain, or lose electrons, they form chemical bonds. And that's how new substances are created. Everything from water to air to your body exists because of the way electrons help atoms connect. A peek into the atom's center, the nucleus. The nucleus is the heart of the atom. It's a small but incredibly dense area that holds both protons and neutrons tightly together. Even though it's tiny compared to the whole atom, it contains more than 99.9% of the atom's total mass. The nucleus stays stable when there is a good balance between protons and neutrons. If that balance is off, if there are too many or too few neutrons, the atom may become unstable, which can lead to radioactive decay. This is when unstable atoms release energy or particles to become more stable. How these particles were discovered. The Electron by J. Thomson, 1897. In 1897, J. Thomson discovered the electron by experimenting with a cathode ray tube, a glass tube with electrical current flowing through it. He observed that atoms gave off tiny, negatively charged particles. This was the first time scientists realized that atoms were made of smaller parts. Before this discovery, people believed atoms were indivisible. Thomson's work proved otherwise and introduced the world to subatomic particles. The Nucleus and the Proton by Ernest Rutherford, 1911 and 1917. In 1911, Ernest Rutherford performed an experiment where he fired tiny particles at a thin sheet of gold. Most particles passed through, but some bounced back. This showed that atoms have a dense center, the nucleus. Later, in 1917, Rutherford discovered the proton inside that nucleus. He found that these positively charged particles made up most of the atom's mass and were central to its identity. The Neutron by James Chadwick, 1932. In 1932, James Chadwick discovered the neutron by studying how certain atoms emitted uncharged particles when hit with alpha particles. These particles had mass but no charge. Chadwick concluded that they were neutrons.